What does the O and the H stand for, Jackson? Right, O is opposite. H is hypotenuse. And A is adjacent. Now, the hypotenuse is always the side that's up across from the right angle. It's the diagonal one, right? People have a hard time figuring out which side is opposite and which side is adjacent. And right now, if I said which side is opposite and which side adjacent, your answer should be, I have no idea, because you didn't tell me what angle we're looking at. Because it changes based on what angle it is. The hypotenuse is always the hypotenuse. You should know where that one is. But like, let's say that that's our angle. And that is a common thing, by the way. It looks like a circle with a line through it. It's called theta. It is a Greek letter. A lot of mathematicians, for some weird reason, like to make unknown angles. Instead of writing letters like X or Y to solve for it, they write Greek letters. So you're going to see theta a lot. So where, we already know this is the hypotenuse, right? Where is the opposite side compared to theta? Kyle? The bottom. It's the side that doesn't touch it. Opposite. Adjacent means that you're touching it. It is right next to, adjacent. So like right now you are adjacent to your desk, but you are not adjacent to the person next to you because you're not touching them. Okay? Adjacent means you're right next to it. So that's what this side is. Because see, it's the side that is touching that angle that we're talking about. And if I was talking about this angle down here, then the adjacent side would actually be this one. Okay? S stands for sine. C stands for cosine. And T stands for tangent. Do not, in my class, say sin, cos, and tan. The only reason why you say those is A, to infuriate me perhaps, which, fair. I do enjoy teasing you, and I'm sure you enjoy teasing me. Don't try it, okay? The only reason why somebody would say sin and not sine is because they don't know that word. It's not like you're like, look, I can't spend the time to say sine, so I say sin because it is so much shorter. It's not. Also, cos isn't even the right sound at the beginning of that word. It's cosine, cos maybe. But also it's just 2 syllables. I think you can say it. Tangent is also pretty easy. And you're going to have to say those a lot, so be prepared. All right. So what happens when you're doing trigonometry is you're trying to find a side of a triangle that you're missing. Sometimes it's just a relationship, but it always can be brought back to a triangle if you need it to be. So let's say, and again, this only works for right triangles. There is a law of cosines and a law of sines, which can be used for any triangle, not just right triangles. Okay, let's say that we knew that we didn't know this angle. No, we're going to have an angle we know. It'll be easier way to start. Everybody go grab your calculator. Oh, do you all have them? You're beautiful people. Oh. It's all right. I bet you there's still 2 people who don't have their calculator who are like, she's not going to notice. We'll find out. I probably won't notice, guys. Let's say this is 40 degrees here. And we know that the hypotenuse is, I don't know, 10, and we're trying to find out this one. All right, so you look at the angle that you've got, the one that we're referencing, and then you think about what sides we have. So what sides do we have compared to that angle? Yeah? Does everybody understand? This is the adjacent one, and this is the hypotenuse. Okay, so which one are we going to use? Sine, cosine, or tangent? Cosine. I love you, but not that much, okay? Like, I don't know why this bothers me so much, but it's been like the bane of my existence, so careful. So the cosine of 40 degrees equals, the reason why I write it like this, I know Thorson doesn't, but the reason why I write them like that instead of just SOH, CAH, TOA, is because it's a relationship, it's a proportion, and it's always written as a fraction, so why not just write it that way to begin with? For cosine, adjacent goes on top, hypotenuse goes on the bottom. So adjacent is on top, that is x, and on the bottom is 10, the hypotenuse. Yep. Because for this angle, I had the hypotenuse, which was 10, right? And I had the side that was right next to it, was the one I was trying to find, which is x. I don't even care about that opposite side over there. So then I looked over at SOHCAHTOA, and I saw that the one that has adjacent and hypotenuse is the one I want. All right, now the easiest way to solve these problems is to switch it into proportion, put it over 1. You guys remember how to cross multiply? So x times 1 is x, and 10 times the cosine of 40 is the other side. Now there are two ways to write angles in your calculator. One is in degrees and one is in radians. We'll talk about what radians are later, but for right now, all you have to know is it's kind of like miles and kilometers. They both measure distance, but they're different units of measurement, right? And degrees and radians are the same thing. So everybody go to your mode first in your calculator. We're going to check and make sure that we are all in degrees right now. Degrees, not radians. So the third one from the top, you want to make sure that you're on the degree side, not the radian. Is it third from the top in your calculators? Okay. Just arrow over. Yeah. Once. So normal, that's just how you write a equation. So scientific terms would have like, it'd be like 1.2 e to the 10 or something, where it would try to, instead of writing like 100, it'd tell you what power it would be to. Engineering, I think, has, I don't know about that one. The floating decimal just says that you can make it always round to the second decimal or always a third decimal or something. Floating means that it changes depending on the problem. Radian degree is degrees. This is function, parabolic. Which one's that? Polar coordinates. This is parametric, and that is sequences. And that just changes. Do you see the variable on here where it says t, x, t, theta, n? Changes kind of what we're working in. It also changes your y equals menu. Connected and dot changes how things are graphed on your graph. I don't know about that one. This one, real numbers, that means that if you were like doing that, quadratic formula equation that we wrote, that it would say non-real when there's an answer, but if you clicked this, then it would spit everything out with I format, where it will actually spit out imaginary numbers as well. Yep. And I do not know what the last one is. Full house, that's it. You got it. All right, so right now in your calculator, to figure out this answer, we're taking 10 times the cosine of 40. 10 times the cosine of 40. Cosine, sine, and tangent are all right here above the comma and parentheses, and you should get 7.66.
You don't have to click them all, right?
Yeah, if there's no multiply there, it will assume that it's without, so that's fine still. You get 7.66, everybody? Be honest. If somebody is sitting in here right now and accidentally still in radians and they're looking at their calculator right now and the answer is wrong, you're about to get every problem wrong in this entire chapter from here on out. Desi. Error? Go back to your mode. Does it have degrees highlighted? Wrote the inverse cosine, and you don't, I think you must have hit the x, you might have x down with the second key first, so it's just regular cosine. All right, now, does anybody know where, how you use inverse cosine and inverse tangent, inverse sine? Do we need to, let's do one more of these quick, okay? All right, let's do another one of those. This is example 1. Example 2. Should I draw a picture that's going to bother you?